So there's a trick for solving, finding the zeros and the x-intercepts of a degree 4 polynomial, a quartic, if you can treat it like a quadratic. When I say treat it like a quadratic, the trick is to let u be x squared. And if I do that, then I can rewrite f as u squared minus 14u plus 45. Then it's a case of being able to factor this using the trick. Two numbers that multiply together to give you positive 45, but at the same time add up together to give you negative 14. So that's going to be negative 9 and negative 5. So if I'm going to find the zeros, then I'm going to set this equal to 0 and see what solves this. So 9 and 5 will make this equal to 0, but these are my values for u. Now, to find the zeros for f, I need to find the x values that make f equal to 0. So if u is equal to 9, then x squared is equal to 9. And to solve this for x, I take the square root of both sides. When you take square roots of both sides, you get plus or minus square root of 9. I'm going to do the same for this. And so if I take square roots of both sides, so these are my zeros. If I go back to the original equation and I say put in x equals 3, then that will make this be 0. That's where it gets the name 0. So I have 4 zeros. There are 3, negative 3, square root of 5, and negative square root of 5. If you were writing this answer in web work, you would have to write input that for square root of 5, especially if it says to give an exact answer and not to give a decimal. So those are my zeros. Now, when it asks for x-intercepts, you get x-intercepts whenever you have real zeros, and these are all real numbers. So I'll get x-intercepts at those numbers as well. X-intercepts are points, and so I just want to write those as points. Okay, and we should be able to see what we've got. Get my calculator. Let's have a look at that. If I come here and I put in x to the 4th minus 14x squared, and then plus 45. And if I start with a zoom 6, we said that there would be an x-intercept at 3 and negative 3, and square root of 5 and negative square root of 5. Now, where is square root of 5? What number is that? Okay, so it's like 2.2 something. And we can see that that is what's going on. I'm just going to refine that window. You can certainly see that's what's going on here. Okay, so I have an x-intercept at negative 3, at negative square root of 5, at positive square root of 5, and at positive 3. And that's what's going on with that. Okay. Let's find the zeros and the x-intercepts of this. Okay. Well, once again, this is a quartic, but I can treat it like a quadratic if I let u be equal to x squared. So if I make that little substitution, then I can rewrite this as 2 times u squared minus 5u minus 3. And I can try and factor this. It's more difficult to factor, but I can still try. This term is 2, so I could have 1 times 2, and then I have negative 3 here. So I could have -3 and 1, or I could have 1 and -3, or I could have 3 and -1, or I could have -1 and +3. Okay, I think that's the possibilities. Now I want outer product plus inner product to equal -5. And if I find a combination that works, then I can factor it. So my outer product is 1. So I have 1 plus -6 equals -5. Well, I got lucky on the first try. So I found a pairing that works. And so I will be able to factor this. So it's going to be 1 times u and 2 times u, and then -3 and +1. Okay. And so now, if I want to find the zeros of g, I can find the zeros of this. So what are the zeros? I set this equal to 0. What will make this 0? Well, if u is equal to 3, that'll make the whole thing 0. So u equals 3 is a 0. What will make this 0? Well, if u is -1/2. If you can't see that, then you're going to have to get a piece of scrap paper and solve that. So subtract 1 on each side and then divide both sides by 2, and you'll get -1/2. But if we're going to find the zeros of g, I need to find out what that is for x. These are the u values that make it 0. Now, we had that u was equal to x squared. So what are the zeros? Well, I'm getting close. So to solve this for x, I take square roots of both sides. And so x is plus or minus -3 is a 0. And I take square roots of both sides. And so when I have a negative sign inside there, the way I write that is I have my I outside. So I do have 4 zeros. The zeros are square root of 3, negative square root of 3, square root of 1/2 I, and the negative square root of 1/2 I. Those are my zeros. Now what about x-intercepts? X-intercepts are only found at real zeros. So I will only have 2 x-intercepts. These are real numbers. These are not. So my x-intercepts will be these points. So if I want to confirm that, I can look at that on my graphing calculator. Okay, it doesn't want to let me out. Okay, so let's go back here. Let's get rid of the previous one, and let's put in 2x to the 4th minus 5x squared and minus 3. And let's do a zoom 6. And when we do that, we're only going to be able to see 2 x-intercepts because that's all we have. So non-real zeros don't show up on the graph. Okay, so again, I can refine this window. And so there's my x-intercept at the negative of the square root of 3. And there's my x-intercept at positive square root of 3. Okay. So we have 4 zeros in total. 2 of them are real, 2 of them are non-real. we only get 2 x-intercepts because you only get x-intercepts at real zeros. Okay. And then for my last problem, what about that? Well, again, I can solve this. So again, find the zeros and the x-intercepts. I can do the trick of letting u being equal to x squared, so I can rewrite this. And this is pretty straightforward to factor now over u. 7 times 5 is 35, and 7 plus 5 is 12. Now to find the zeros, I'm going to put this equal to 0 and solve. So 7 is a 0 for u. U equals 7 is a 0. U equals negative 7 is a 0. And u equals negative 5 is a 0. But if I'm going to find the zeros for h, I have to find the zeros for x. So x squared is equal to negative 7. And x squared equals negative 5. And to find the zeros, I need to get what x is, take square roots of both sides. So x is going to be plus or minus the square root of 7i, and x is going to be plus or minus the square root of 5i. So my zeros are going to be the square root of 7i, the negative square root of 7i, the square root of 5i, and the negative square root of 5i. Those are my zeros. There will be no x-intercepts because none of these zeros is real, and you only get x-intercepts at real zeros. So let's see if we can have a look at what this looks like. So let me get rid of that. So x to the 4th plus 12x squared plus 35. Okay, if I do a zoom 6, okay, we're not seeing much at all, are we? Let's see if I can expand, or might see where we have some points. Okay, it looks like I'm going to need to expand this vertical window. I might take that up to 100. Let's see if that'll give us, okay. Okay, this has no x-intercepts, just like we predicted. Okay, and if the question had been instead, where is this? Where does that happen? Well, when does that happen on the graph? When it's above the x-axis. When is this above the x-axis? Everywhere. And so the answer to that would be that. All right, so I'm going to stop the video there. I think that's enough.